Hello and welcome to the second part of Agile Software Engineering for Legacy Code. And this time we'll be looking at the code level patterns. So really this is for developers. What are the main cases that you have when you come into legacy code, when you have to add testability afterwards? And what are the main cases that you encounter and what you do about them? So this is really about code isolation patterns. Remember, we wanted to add testability to existing code, which has a lot to do with cutting dependencies and making the coupling of code different. And the main cases will be, the topics we'll be looking at is constructors, bad constructors. So when you even instantiate an object, there can be problems. Then what do you do when you have to replace a part of a method? What do you do with global state? How you deal with test for parameters, if you have to supply parameters in a test that are hard to create. And then finally, we're looking at the law of Demeter on when you write new code or what to even think as far as dependencies, what is the goal and what you need to look for. So again, as I said, the focus here is adding test isolation to legacy code. So if you have this yellow box, the code under test up there, and it depends on several dependent on components, which what we call docs. It's hard to test the cut because you have to set up everything that the code depends on to behave just right, and it can be many layers down to be able to ensure that whatever happened in the code under test is right, if it called the right methods and everything. So this is really the problem. And because when you bring legacy code under test, you have to make changes. But typically in legacy code, especially without tests being in place, so the change that you make must be so least intrusive, very safe, and local, so that you can actually do this safely. Because just imagine if you make a big change to add testability, the change itself to add testability can create bugs, and this is something that you try to find and not create. So we're looking for now in this video here, we'll be looking at are code change patterns that are specifically targeting test isolation. It doesn't make code all better. It doesn't do everything that is considered with good design. It just to do the one thing that is needed to create isolation in many different cases. So test isolation. And so the book, the right book, Working Effectively with Legacy Code. You see there, everybody who should, if you want to get seriously into it, you should get that book and read it. That has a lot more stuff in it, and this talk really talks only about the things that you need to bring testability and not all the other things. So let's look at a case, kind of a typical case, but it shows you all kinds of problems that you can have with code that looks kind of innocent. So let's say here we have a class that is a workflow engine, and it's the constructor. So if you're not familiar with Java, in Java, the constructor has the same name as the class, so in ABAP it has a fixed name. So what's wrong with this code? Well, let's look at that. You have basically everything almost is wrong with that code. First of all, it has a parameter, and then you can wonder, hey, how can I supply, if I want to test the workflow engine, I want to create it, do I really need a servlet request? Why do I need a request? How can I create it? So this is the first thing. It should be actually underlined as well. But since we're looking inside only, for now, let's look at what happens there. So the first thing it does is it goes to the system, so file system in this case. I get a file from a global configuration path. So already I have a problem. There's a path that I have to know where a configuration file is, and then I have to go get the file, and it's only file handle, of course. But so already the test would depend on this global configuration, the path, and the file actually being there. And this is the second line, of course. Then I read the file, I get the configuration, which means I read it and parse it and do whatever. And I create a configuration instance. Let's say that's an object that holds the configuration. Now, a configuration object is a good thing because you can change it, but to get it this way is a bad thing. And then let's say there is another thing. I create an object, a model reader that somehow takes out of the configuration something that it creates a model reader from, and of course, and now I'm creating a dependent on component in the constructor. that I maybe don't want to test. Maybe this thing is heavy, maybe this is difficult, I don't want it. Maybe I want to test later on if the model reader, the reader was used in the right way, then I have to be able to use a test double. I can't do it because it's doing a hard call here to the class to create an instance. And the same thing is the next line. I'm creating a transaction manager where I put this configuration reader result in there as well, so possibly even both. And so the transaction manager depends on both. So now you see in the end, I did a whole bunch of things to come to this point. Okay, I'm setting one variable, the transaction manager instance, that is dependent on a whole bunch of things that come from the environment in complex ways. So if I want to do this and influence this, I have to set up this whole environment for a test. Of course, this is very bad. And then there's two more examples at the bottom, like if you would even depend on global data, so you can look at some global debug mode and maybe even look at the session. So of course, the parameter that comes in at the top, you get something out. So number one, you have to supply the servlet request, and then you ask the session for something. And not only that, you're not asking just the session for a value, which would be okay, but you're taking a pointer to the whole session, which is also bad. So this is like a piece of very bad code. Now in production, you would think, okay, you know, the system works, just leave it as it is. If you think about testability, all these things are wrong, give you trouble. Now it turns out that the concern of good design is also the same thing that you get for testability. So it drives the same concerns, and it means that if you drive for testability, you also get good design, separation of concerns, and all these things that are important. So what we need to do now, and we'll go through those cases, not through all of them just, but through a whole bunch of others as well, change the code so that none of these things has to happen in a test. So now I'm just really considering this one case, this constructor. What can I do if I have this class, I want to put it into a test? So the first problem I have, I need to instantiate even this object so I can possibly test it. And I only want to make small and safe changes. Well, so I have a situation I want to replace, I want to just abstract it a little bit, and it's called extract and override constructor. So I have a constructor I have trouble with. The situation is I want to replace part or all of a constructor. And what I can do, at least in Java, is I extract the code that I want to replace into a protected method. So my test can be a subclass, and in the subclass can override this method, the protected method, and do nothing, whereas the production code can actually do whatever it did before. And then so I inherit the test double and override this method. How can I do this? This is how I described it. So in Java, if you look at the picture on the right, say M1 is the method that is supposed to be called from the constructor. And in the subclass B, which inherits from A, it basically, when the code calls, when you create A, and you can create an instance of B, and it wouldn't do what in this case, the make transaction manager, which encapsulates all that bad code. Now the trouble is that only works in Java, and in ABAP and C++, it doesn't work. Why? Because it's a matter of philosophy of language design. If you think about inheritance, and the constructor A calls a method that is defined in its own level, if it's overridden, if somebody override it, should it call the lower level or not? Some designers, including ABAP and C++, they thought, nah, we don't want to do this, because how can the lower level M1, it could run and assume that its constructor is run, but it didn't. So you could get really strange situations, and it's better to have just called them everything and see only the methods that are on the same level or higher. This is the philosophies of ABAP and C++, and Java lets you call down. So it means if you have a method overridden, it will be called right away, even in the constructor. So this means that this solution, it works nicely in Java. What you don't like, you put into a method, into a protected method, and then in the test double, which you make inherit from this, or in the test case, you create not this class. I shouldn't say test double, that's wrong. When you create a test, you don't create the workflow engine, but a workflow engine test, which is a subclass which just overrides this one method. So then you got rid of this of this one piece of code that you don't want. Another solution is to pass in the dependent components into the constructor. So basically, let's say you want to replace all or part of a constructor. Well, what you can do is you create, for instance, a second parameterized constructor, or the thing that gives you trouble for the test purpose. You can pass it in that everything depends on, and then you just pass in. So maybe a dummy object if for tests you don't want to do anything. And if it's not passed in, it does the normal thing that you had in the code before. So if you look at the code on the right-hand side, the thing what this all was about, what wasn't happening in the constructor, it was about the transaction manager instance. Well, for the test, you can pass it in directly, and in the production code, we just leave the code as it is. Remember, what we're doing is not really making the code better, because you would also think, well, why, even for the production code, I should do this differently and pass in the transaction manager. But for now, we only look what is the minimal step that I can do to make something testable, so I can do the next step safely. And again, make sure that this is super safe, and you have, basically it's impossible, hopefully, to make a mistake that breaks your existing code. So basically what this is doing here, you have either, in this case, you have optional parameters, so you see it as transaction manager tm equals null, this is equals null, how you specify an optional parameter. So if it's not given, then you run through the production code, and if it is given, then you just take it. So you have this solution for ABAP and C++. In Java, you can write a separate constructor that is overloaded, or you can either a separate constructor by overloading that, so you have the same constructor name, but you pass a parameter, so it will pick that. Or you can even do the solution that we just looked at before. Now, what should constructors really be like? They should really only initialize their own internal state, but not create their collaborators or even get access to, meaning it is okay to ask somebody, give me a database service or something like that, but don't create an instance, anything. You don't do a new in the constructor, because that means that you always depend on classes, on things that you don't want to happen typically in tests. So a constructor shouldn't have complex logic, no static calls, no if loops, and definitely no new keyword. So no new is the first and most important thing. So basically what we can say is that wiring objects or services together is a separate concern that should be handled separately. So don't put the new and, like the parent object creates the children object and so forth. So it goes through the whole graph down, and everybody creates their whatever they need. Their instances, that means the structure, the code that decides what the structure of the graph looks like for the services, basically, how they are wired together, is spread all over the place. All the news that you have everywhere. I'm not talking about the news that are like data objects or something you need locally for computation, but I'm looking for things that are like either logical singletons or big services, and you shouldn't just create them here and there and basically have the logic that decides which one to use is spread all over the place. And we come to this later, that we want to actually have factories, and there are some frameworks like Juice or Spring for Java that helps you in doing this. A pattern that we will look at is dependency lookup. And this is an example of a single responsibility principle. So we always say, yes, a class should have only a single responsibility. So you should have, let's say you have a customer object, it shouldn't have the billing mixed in, for instance. The billing should be separate. And if they need the address of the customer, they ask the customer, but don't put everything together. And so to realize that wiring services together is also to be considered a single responsibility that shouldn't be in the objects is an important thing. So there are two ways to actually go about this. This thing about managing who knows about who and who creates who, so to speak. If you pass in a dependent component into a constructor, it's good for one class. But what if I, for instance, need a replacement several levels down? For instance, I have a whole graph of services. They all do something, and they all call the logger, and the logger writes into the file system, the real production logger. But I don't want to write into the file system when I'm doing a test. I mean, you can say change the logger and have a switch on it to say don't write anything. Just store something the last 10 lines that I can check or so. But you can also say, I want to replace that logger in a test with my test double. It's very specifically look, did a certain call happen, whatever, maybe do a stub that does nothing. So in the context of legacy code, dependency lookup is less intrusive than dependency injection, which happens typically if you do it directly in the constructor, where you have to have a parameter that the dependency comes into the constructor, because then every client has to be changed to supply this thing there. Now, an optional parameter is not a problem because only the test can supply it and the rest of the code can stay the same. But another way to do this, especially if you think about several level down problems like this, or for instance, here in this example, you see a logger, you have a mailer, you see, for instance, the code sends mail, you don't want it to happen in a test and so forth. So things that are lower level that you want to, if you run through an integration scenario, just not a unit, but you don't want the mail to go out, for instance. How do you do this? Well, it's dependency lookup, it's called, the pattern, and it means basically instead of everybody creating the ones that they need, you have to ask somebody. And so if you look at this, how can we replace a thing that is further down? You basically have to, the create or the new, you have to add an indirection to it. So for instance, you can have a static factory method on the mailer class or on the logger. Actually, this is a mistake. I see that it says logger on the top here of the class, and I have a get mailer. So it should actually say mailer and get mailer. So it's a mail class, and there's a static method that gives you an instance, right? So it is a logical singleton. And so, but it also has a set test mailer. So if I for a test need a test double that doesn't send any mail, but it just remembers that, for instance, I would have sent one and this was the text or something like that, I can check it later on. The test starts first by setting the test mailer. So the test doubles it wants to be used are all registered, if you will. Then it starts to call the function. They all go through. If somebody needs a mailer, they will call get mailer. The get mailer sees, aha, I already have a mailer instance. Then I use it. It happened to be the one that the test installed or put in there. If I don't want to have create, I can create one. So it's the same kind of logic. If equals null, then create. Otherwise, use what is there. And so this is the factory pattern, the factory method or factory class you can come to later, that gives you this functionality. And it's very safe because it's a very small change. You replace basically a new with a get call, get mailer call, or something that is a static call. So where would you use this dependency lookup? Well, you would use it for service classes that only exist once in a system, so logical singletons, and also dependent on components that are used many places. So if you have many places that use something and you want to replace it, and for every test this is a problem, then of course you want to be able at one point to say, I don't want any of these. I want all logger calls to go to my fake logger. I want all the mailer calls to get to my test double and so forth. So they all need to go to this indirection. And also important to see, it's not needed for data classes. So if you have data objects that you pass around, you don't need any test doubles for that. You don't need any isolation, of course. So never isolate against a vector class or a data class, a customer object that has nothing but just, it's a data object, but only things that have a service character and actually do something you don't want in a test. Now, we have a new problem case we want to consider now. I am in a big, long method, for instance, and there is one thing happening, a few lines that I don't want to happen in a test. So I have a very large method, and I need to replace a part of it for a test. If you look at the code on the right, let's say this is really bad code. We have hundreds of lines, almost 1,000, 800 lines here in this example. And there's in there somewhere in the middle, it connects to a database and gets an exchange rate out of the database. And this is often the case that in a long method, you have a few lines that you don't want to test. So, obviously you don't want to go to the database in the first place because it's slow, but also you don't want your test to depend on exchange rates that may change daily, at least if they have a live feed or something. So you really don't want this. What can you do? Well, there's a pattern that's called extract and override method. By the way, these names, they come from the book from Michael Feathers, so it's really a good thing. it's a mnemonic way to remember what are you doing, and it's good to know then so that you can talk to other people about it. So what do we do in this case? Yeah, you do an extract and override. So the situation is you want to replace part of a method. What do? Well, the few lines of code you want to replace, you take into a new instance method. You give it a good name and call it from there. And so you pass the parameters that are needed. And then for testing, you can override this method in the test double subclass. So what does it look like in the code? Well, you see a method get exchange rate euro USD. Why is that name? Well, if you look at the code up there, euro and USD is a constant. And it's kind of strange probably. Maybe it would be always a variable. If this would be a variable that comes out of the context, if you have variable names there, then you would pass them into this method. But now it's constant, so they should be in the name so you know what happens in this method. So the code that you saw up there, it just goes up there one-to-one. You just copy paste, and actually there is great refactoring tools in, for instance, ABAP and Eclipse, or in Java for sure. Eclipse has that, many other environments too, that you can just mark code, you say refactor extract method, and it does it automatically. You can just type the method name, and it does that for you. In fact, many tools even recognize if you have things that depend on context, and then they put them in as parameters. So this is really convenient. And then, of course, in the place where you had it before, you call that method. So if you look at the bottom there, it says double exchange rate equals get exchange rate euro USD. This is what you just created up there. And then this method is a protected method, so that in a testing case, so when you instantiate this thing, you can override that, and then everything you don't want to happen, you can override with an empty implementation, or you can put something specifically in there that you need for the test. So this is a nice little way to get rid of sections of code. Another problem case we're coming to now is code depends on global state or static methods. These are a little different, so and some things are not so easy to spot. So some global state things are obvious, blatant global variables, and sometimes static members, but sometimes, static methods are, for instance, a single create method that hangs on the class level is a static method. So you have to realize, hey, wait a second, this gives me a single, maybe this is what you want, but maybe it does something you don't want. Maybe if you want this to be replaced in a test, you have to make provision to have that done. Like, for instance, if we look at the get mailer that we had before, we have a set test mailer. So it is a singleton, it is a static method, that's okay. We keep it, but we add another method to replace whatever it does or returns for the test. So sometimes you want the static method in the case of the factory patterns and dependency lookup, but sometimes these things do something. For instance, if you look at the initial example, going to the file system, reading a configuration file, you don't want that. So this is another static method, and it can system is the ultimate static, anything going out into the context. So we have to do something that we need to do to bring the code under test with minimal effort. And refactoring to a good design is a later concern. So what are we looking at specifically? In this case, we first look now at global data. So I mentioned before the static methods as in it does something I don't want. Either I have to change it with put a setter next to it that I can kind of disable its behavior. So this is one way to do it. And then I can change its behavior in a test. This is what we saw in the set mailer or the set test mailer. But if I have access to global data, it's different. I have just a name in the code that goes out somewhere and depends on data that is global in some way, or at least more global than the class. So sometimes some languages have that there are different scopes, but outside of a class, so you have an instance and you have the static level, and it's maybe something like in JavaScript, you have the global variables that are global to the whole application. And so those things you don't want, or you want to be able to handle somehow. So what is the solution? Well, stage one is if you basically say, if it needs a certain value, then the test can just set it. I mean, why not? If it's just an isolated test, just write the variable there you need, and you have to know it, of course, and you have a helper method to set up the code that the state that you need for the test. And this allows to make some tests work. a better stage 2 is then to say, I'm going to encapsulate all relevant global state in a context state class. Now, normally context is also a bad thing, but you have to think about what really is going on here. Is this really configuration? What am I doing with this global data? Is it configuration that just goes, basically flows inward? Well, then call it that and manage the configuration in a good way. Or maybe it is actually stuff that is used to write into and somebody else reads through it. Well, then it is basically a data access object that you pass from one to another. The point is you have to realize what it's doing. You look for logical groupings. Maybe those 3 variables are configuration. Those 5 variables are actually data access objects. They are data objects that are passed around. And so what you can do there, you take a group and put it into a class, give it a good name. And this is really the challenge. You have there where names matter because you want to say what it does. And then you can redirect the changes, the access to it in the code, so one by one. How does it look like? Well, let's say, for instance, we have a before and after case. This is an example from C++, I believe. No, actually, it's not. You have some integers that are global and some class that uses them. So ABC is the global state. And C1 is using them and C2 is using them as well. So you see that there's coupling between C1, the methods, M1 and M1, even of C1 and C2, over those global variables. So what can you do? Well, let's call them data class. It's a bad name, of course, but it's just an abstract example. So you would, in the class C1, you want the context to be passed in. So if you think this is the way they collaborate, then maybe somebody else should create this object, this DC object, or data object, we could say called DO or something, and say this is a whatever state, whatever the semantics are. And then you see that in the access of the different variables, you say dc.a instead of a. So you redirect the accesses to the instance that you put in there, and then also the other method gets it put in, and so everybody talks through these different handles to the data. This is the way you decouple access to global data. Now we're coming to a few more difficult cases. I have a parameter I want to call a method. So I already mentioned either for a constructor, of course, which is also a method, but let's say I managed to instantiate a class. I want to call a method now. But I have to supply a parameter because that's the way the code is written. So and sometimes it's not easy to create those parameters. So if it's an integer, well, you put the value. But if it's, for instance, an HTTP request, well, you can't create it yourself, at least not traditionally. So the parameter can be hard to create. It can be difficult or expensive, or it can be a framework class like HTTP request that you don't have control over. Or it has lots of dependencies itself, and then if you want to create that, you have to do this as well, and take care of that, and so forth. So all those things that you don't want. Or another reason is why you would want to replace the parameters if the class or the method you want to test, it does something to them. For instance, you pass in a logger, but you want to see does it do the right thing. Well, then you want to pass in a test double to make sure that actually a certain log call was made, for instance, in case you want to test that. So you need to test the effect of the method on this parameter, and that's called the spy. Spy because the test double spies on what's supposed to happen. It's recording, and then you can ask the spy later, did this thing happen? Now, mock frameworks or libraries can make it easy to replace classes. And then basically to say, if this method is called for this class, then do this other thing, and there are some tricks to that. We want to show how to do it manually so you know what really happens, and to also gain some better code structure because of it, so that you find a way to to clean that dependency up in the code a little better. So there are different cases that we have to consider for the type of the parameter. So let's assume we have a method, or in a constructor or in a method, doesn't matter. We're looking at one parameter now. It can be a simple interface. Well, that's easy because I can just implement the interface in a test double, and whatever methods I need, I really implement. The other ones I can just leave empty. So that's easy. Then I can just supply my test double. It's already an interface. That's great. The class is, it's a class, but it's not final. Well, what can I do? If it's not final, I can probably create a subclass for the test double. It may be very complicated and everything and have many dependencies, but I can hopefully create a subclass for the test double. Well, it could be hard to instantiate, which is a real problem. For instance, if this parameter you want to supply itself has a bad constructor, so you have the problem there as well. So you want to fix this, you come into a new problem, you have to pass a parameter, and you find out this class that you have to pass in there, this instance, is itself hard to instantiate. And you can see how this goes from one to the other. So what you can do then, if you have a class here and you can change it, you can extract interface. What does this mean? We'll look at it in detail in a minute. Well, I change the parameter to an interface. That class, of course, implements the interface, and therefore it fits, and the test double will also implement the interface. But I must be able to at least change the source code of this class so I can say, you know, it implements the interface. If I cannot change it, for instance, if I get a library that I have no influence over, I cannot change the code there, then I cannot use this pattern. And that's the third thing. Either the parameter is a huge interface, it's hard to fake because, for instance, I need certain behavior, or the class is final and you cannot change it. Like I mentioned, it is from an external library. So there is no thing you can do. You don't have the source code, you cannot change it. So you have to pass in, like your code that you want to refactor, it expects something that you get from a library, and you cannot change that. So that's the third pattern is called a dep parameter. And we're going to look at these now. So the first is, let's say, to make the problem more clear, what we're looking at is I cannot create an instance for a parameter, or cannot, it means it's hard for me. So in general, for instance, let's say here I have a method that gets an HTTP servlet request. How can I replace this for a test? Now, by now, actually, there is test support for all these things in the libraries. So the providers of the frameworks have supplied that, but let's assume we don't have that, so in another case. And so in an abstract form, we have this, that if you look at down there, there's a method, M1, it gets a dependent on component, doc1, and then of course inside it does something with it. It calls a method on it, like an M2, for instance, in this case. So you get a parameter you have to create, and then the code is doing something, so you have to maybe implement the method, or depending on what the test and what the method is supposed to do, you have to be able at least to change and decide what happens in a test there. So what can we do? I already mentioned case A is easy enough. You can just implement the interface and supply a test double that way. That's easy. That's why we're looking at case B now. The doc1 that you need to create and put in is a class, and you can change it, so you can add the interface. So what do you have to do? And this is actually a very safe thing. This is one of the safest patterns because the compiler will tell you where you made mistakes. This is a great thing. So what do you do? Step number one, you look at the red box on the bottom there. This is the code example. We'll go step by step, go through it. So first of all, solution steps is you create an empty interface I1, and that's already, you see it in the code already. It's up there, interface I1 on the top of the code. Then you make doc1, so the class that you want to replace, implement it. You change doc1, and this is the second piece of code there. Public class doc1 implements I1. So implements I1 is that one little change that we needed to make to the class to make it usable there and injectable as a parameter. And then you create a test double doc1, td to doc1, that implements I1 as well. So this is the next thing underneath. You see the class. And this will be our test. And then you compile everything, it should be fine. You haven't done anything yet except create those C pieces. And still at the bottom, it's still the old parameter. So now you're ready to actually make the changes. So still M1 has this parameter type doc1. Step number one, or in this case, step number 4, considering the preparation, now you change the place that you want to change and put the interface in. So you change doc1 into an interface. You can keep the name of the variable, doc1, which is a little strange maybe, but you change it into an interface name. So if you see in the code, it used to be doc1, now it's I1. You compile again, it should work fine, because now doc1, it implements the interface. But you may get errors. Why? Because if you look down, let's look down. If you see I1 has no method in it, right? And so the test double doesn't implement anything. If you look down in the code, that doc1 parameter, it has a method that is called getParameterValue. So if you want to replace that, you will get a compile error, and you will actually get it when you compile this after you change to I1, because the compiler tells you, hey, on the interface, this method is missing. Okay, and then you say, all right, I put the method definition in the interface, and I add the implementation to the test double. And of course, the real class still implements the method as it did before. There's nothing to be changed, in Java at least. So you have this one member that was missing, and you find it by, you compile it, and the compiler tells you this doesn't exist. So you fix the compile error, you move the member definition of doc1 the compiler complains about to I1. So you add it, you move to it, you take it away from doc1, you move it into I1. And of course, you also implement it in doc1. And so now this is, we're at the end, the thing is done. We have changed the parameter from doc1 to I1. The interface has the method, the dependency, the way how this class, any class, depends on doc1 is encoded in the interface. You see it there. This is what I really need. The one method, getParameterValue. And then the test double just implements that. So now you can stick in either the real doc1 or test double as you want. And then, of course, you can implement all methods that go outside in a different way in the test double. This is the solution for this case, and you can see in the class diagram up there, you have the interface, and it's once implemented by doc1, so the real class that does probably, I have 100 methods in addition to that one, and then also the test double. And remember, this is only one method. So now let's say you have another method, M2, and it needs another parameter, a method, a member, from doc1 that was not in the interface. So now the choice is, do I add it to I1 or make a new one? My personal, I mean, people have arguments about that. I would say, as if it logically fits together, then put it in I1 as well. But it has to kind of, this I1 should not be just a hack to make something testable, but go in the direction of better design. So give it a good name. Like in this way, it could be, for instance, context dependencies, and then you get a parameter value. Maybe you get later some configuration data or something that you can also add to it if you depend. So you have to look at the class, what does it depend on, and maybe say, okay, those two things actually, and those methods, they belong in the same interface. So everything that kind of belongs to the same class anyway, you can put easily on the same interface. So everything that is needed from doc1 in this test, you would put in the same interface. Now we come to the most difficult case, and you see a lot of stuff here, so I'll go through it step by step. And this parameter, this pattern is called a depth parameter, and doc1 is a class, but you cannot change it. This is like the library case. So let's assume you have this example on top right. You have a servlet request, and you have to stick it in, but it comes from a library that you don't control. Maybe you're even your object is even typically in a framework, and it gets called. So you don't even call it directly. So you can't even change the call. So what do? Well, for the test, you want to call it individually. It's hooked up for the production code. It's hooked up in the framework, so it will be called. But for your test, you want to call it directly, which means you have to supply this parameter. And what is the abstract form? Well, we can say we'll call it doc-fixed. You cannot instantiate it because it's really complicated. If you look at the servlet request, it has like 100 methods or some, 100 methods on it. And you don't know what it's doing, and it depends on, it's like a million things from the session and the server and whatever. So let's say you can't do that. And so in the abstract form, the box underneath, you have a method that depends on a doc-fixed parameter, and you cannot change it. So you cannot say implements interface or anything like that. Well, what can you do? Basically, you replace the parameter by a new interface that has two implementations. So again, you create an interface because that's the place where you can switch. But the lower right picture shows what we're actually doing. So in the productive case, there is a class I1prod, which is actually a class. It that's the name, it's a little strange maybe, but this implements that interface. It really delegates the call. So whatever it needs to do, it delegates. There are calls that call the real docf. And for the test, you can supply a test double, I1TD, that just does what you need or want, for the test. So you still put an interface in, but you put the one thing that you cannot control, you put a class in between that basically, if it is needed, it's a pass-through class that calls the methods, and in the other case, the other implementation does nothing. So let's look at the code, how this works, and basically you can read it top to bottom on the left-hand side. The class we're concerned with is class XYZ, and it has a public method called M1 that had this really hard parameter in it, and we already changed the code. So this is it shows the new situation, not the old one, but it shows the new situation, how everything works together. So it shows that there is a parameter I1 now, the interface is already put in, it changed. But you look down, you see, I1 still calls M2. So I realize, hey, M2 must be in the definition of the interface. Then, of course, it must also be implemented in the test double. And it's something that in the I1 prod class has to be implemented. So it calls the real implementation. So the interface definition you see underneath, that's I1, and it has the method M2 in it. And of course, in real life, it would be more complicated with parameters and all that, but it doesn't matter. It's the same thing. And then you have the test double. So you see the implementation of M2 in I1 TD. Maybe it wants to do nothing. Maybe you want to have like a spy that checks, did it get called? But that is up to you. That depends on the case, of course. What's interesting is the last part there, I1 prod. This is the delegator class that you defined in between. And so this is a new class that implements I1 as well. And you see there it has a private member function, member variable docf. So this is the reference to the real implementation. And in the constructor of this, so the real code, what this does, and you have to change it that way, when you create the real production instance, you pass in the reference to the real implementation of docf, the original one. And then you remember it. So this is the docf reference. And later on, when any method is called from the outside, from the client, and they don't know that anything changed, they are delegated. So you see in the M2 implementation down there, it calls docf.m2. So all the calls from the outside, they call M2, and then it gets rerouted to docf M2. Only the constructor supplies the real docf. So you have to change the place where normally you would inject the docf that this I1 prod is also created and supply the variable docf. But that's basically how this works. So by changing this to the interface as well, and then also, of course, the places where you call this method, you can supply the interface, or you can supply the methods, the instances that implemented this interface. So the production code you can pretty much leave the same. Yes, okay, so you see, let's look on the right-hand side, the calls to M1. It used to be object.m1, where the argument docf was the class, that was the type of the argument, and now it's I1, the interface. And the actual parameters are created this way. So you have, in a productive case, you would create an I1 prod and pass in the docf that you created before. And in the test double, of course, you would only create the test double, and both they fit into the I1 parameter. Okay, so this concludes the patterns of different, how to deal with which situation in the code. I want to mention one last thing in how to prevent the mess of dependencies in the first place. So of course you're making all changes now, but you should have something in mind. How should it be? And if I write new code, maybe how should it be? So if I change something, which direction should it go? And it has to do with what's called the law of Demeter, to limit dependencies to a minimum. And maybe you've seen this before on another talk, but I'll repeat this anyway. It's one of my favorite examples about coupling and dependencies. Let's assume we simulate a dog owner and a dog. And the dog has a head, a mouth, and a tongue, and the dog can bark. Now, the bark method happens to be on the tongue. And the dog owner now wants to say, hey, the dog should bark, so they will write and we will write the code, dog, get head, get mouth, get tongue, bark. So we are happy, we think it's great, we have the code working, we should go home, it's wonderful. Actually, it's not wonderful, it's really bad, because what happened now is that the client code, in this case the dog owner, knows about all the internal structure of the dog, that it has a head pointing to a mouth, or at least I have to get method to get to it, and I have to go 3 steps before I can call the bark method. So that means that if I want to change anything inside the dog, I want to do refactoring, clean up something, I have to suddenly change the client code because I exposed internal structure. And just imagine if you do this with one call, if a class or a component does this at all, the next person will call another way and another way and another way, and soon you have like threads of dependencies running through your code in different directions, all kinds of mixed up, that basically put the current design in concrete, because whatever you change, you have to change all these clients. And that's very bad design. And this is all the dependencies that you don't want. And when you think about testability, you will run into these and say, oh, if you do test-driven development, for instance, you would never write this because you would immediately find out that it hurts immediately when you try to write the first class in the method. So what are the implications if the code is like this? Well, it's very hard to extend and change because all the clients know about internal structure. It's hard to test because I have to set up all these things to get something done. And no reuse is possible. If I want to take anything out, for instance, the mouth, I want to implement a cat, I can't take this mouth because it has a tongue, but the tongue barks, and the cat doesn't bark. So it sounds silly maybe, but if you think about it, the component has a fixed dependency on something else that you don't want in a new context. And because you don't stick the dependencies in, but you have them wired from the inside out, that ties everything down to context, and this is a very bad way to code. So what is the solution? Well, obviously, obey the law of Demeter means that everything that is available, so it's supposed to be, basically everything that's semantically visible at the top level should be also a method at the top level. There should be only one stage of calls to it. So you have the bark method at the top level. So if you do this and go in this direction, then you should have a lot less of all the dependency problems that we looked at before in the patterns to deal with. So summary is this: most trouble for testing and reuse really comes from 2 things: referring to concrete classes rather than interfaces. So if you say a create, you refer to a class, so then you have already a binding to a class and all over the code. So if you do this first step, then say everything that is a service or anything that I want to, that does a big thing in my code, nothing trivial, I expose as an interface, you immediately have the right thoughts. Then you need a factory to create the instance, and already there you have the place to replace something. And so just the simple step to put an interface instead of a class in references and then have one place where you create it is a huge benefit in testability. And in fact, I would say even when you write new code, make sure you only offer it through interfaces so that you can test it yourself. You can provide a test double, or other people can write test doubles. The next thing, of course, is we saw that law of Demeter violation. So even if you have interfaces, if you walk them and you expose one object after another in this chain of dependencies, then still everything is tied down, this time to interfaces, but the structure is locked. That's not a good thing. So in order to isolate components or classes, you should do these things. Provide an interface, what you want to be isolatable, I said that. Classes should never create their dependent on components directly from the inside. So anything where a new is in a constructor, unless it's trivial data object or something like that. But if access to service or something should never be in a class, definitely not in a constructor, but also not in other methods. You should get them from factories, and then you can eject there, you can test doubles. And you should encapsulate all access to global data or any kind of global environment. And from a component perspective, this is everything that is really outside that you get access to by name. And basically a static method is a different static name, but the code has to be there in the context. So this is something you should avoid at all costs. There's one thing that you need, that's the factory. And typically, this goes beyond the scope of this talk here, but if you look good ways to do this is basically the application is the top context. And so if you need global data of any kind, hook it up to the application object that is as global as you want to go. But then if you want to put a certain service into another context, at least it's a difference if you go to a name or if you get a context object given in. And of course, observe the law of Demeter to provide clean and complete abstractions. So if you do work in Java, then I would totally recommend use dependency injection framework. So look at Spring and Juice, and those are Juice with a G. Those are really great frameworks that lets you, even in legacy code with a few small changes and annotations in code, let you cut open dependencies. And this is quite low intrusion way to deal with dependencies and make your code testable. For ABAP, it would be really dependency lookup, where you change the replace the new or the create object with a factory call, and then in that place you can change and inject the test double. And this is really all you need to avoid those dependencies. And finally, I would say read those two books. Those are the classics. The one with all the refactoring patterns that I talked about is in the legacy code book. And just the thing, what is clean code, what is good design as far as minimize dependencies, what to look for in good code. The clean code book is a total classic from Bob Martin, Michael Feathers and Bob Martin. Those two guys you should really have, every developer should read that. So thank you very much. I hope this was useful to you. You find a lot of these slides, this content in papers, code examples and everything on the wiki, in the pages for ASE for legacy code specifically. And if you have questions and discussion or whatever, you can also go to our ASE Jam in the different stack if you want, ABAP or something, for tool-specific questions, but also just in general, ask a question and maybe somebody in the world out there, or send us a mail. We'll give you an answer on how to crack a certain special situation. So good luck with all your dependency reduction efforts. Thank you.